Like imaginary.
I'm recording. No, this does not say Polynesian. This is polynomials. Okay. Have you heard of a polynomial before?
Yes.
No.
Sadly, yes. Okay, so polynomial, what a polynomial is it's made up of terms. Maybe, and it can have one or more terms. One or more terms. So I guess the question is, what's a term? Algebraic terms, if you think back to chapter 1, algebraic terms are things that contain numbers and or variables, and they can have exponents in there, okay? So examples of terms might be 5x, negative 3x to the 5th, 7. All those are terms, okay? An algebraic term has variables in it, but a term is numbers, variables, exponents, that kind of thing. Okay, so a polynomial is made up of these terms added or subtracted together. So it looks like now this one has every exponent from there down. They don't have to have everyone, but this is a polynomial, okay? All the exponents need to be whole numbers, positive whole numbers. Where are the exponents, by the way? Which numbers are the exponents? 3 and 2. And there's a 1. Does anyone remember what the numbers in front of the variables are called? In front of the variables. So the x would be the base, you're right, but what would the number in front be called? Yes, coefficient. Good job. It's a coefficient. Okay, I'm recording now. All right, so notice something about this polynomial. Okay, all the exponents are in order, right? From biggest down to smallest. That's what we call standard form. So if it's not in standard form, you need to put it in standard form. So standard form goes from biggest exponent to smallest. I told you there was a good bit of vocabulary in this section. So we're kind of defining polynomial and some parts of the polynomial, okay? So far we've done polynomials in standard form. We've defined terms, right? We've defined what a polynomial is. What else? Let's see, the coefficients. What is this number on the end that does not have a variable hooked to it? What is that called? It is a whole number. Give me another name for it in math. What kind of number doesn't have a variable? Do you know? Constant. Okay. Constant means no variable. No variable. Now, when it's in standard form, the very first coefficient is very special. It's called not just a coefficient, but the leading coefficient. And it's called the leading coefficient because it leads the equation when it's in standard form. Does that make sense why we would call it that? Okay. But it has to be in standard form. So we're going to practice putting some in standard form first and identifying these parts before we move on to what we're actually doing today. One more term. Y'all ready? Ready or not? The biggest exponent that you see is called the degree. Okay? So the degree of the polynomial is the biggest exponent. It's always hooked to the leading coefficient. Let me give you an example. Let's say I have 15x minus x to the third plus 3. First thing I want you to do is write it in standard form. Let's make this 15x. Write it in standard form. Standard form means biggest exponent first, and then they decrease from there. So what starts? This is the biggest exponent, right? So it's negative x to the third, then 15x, and then 3. What are the terms of this polynomial? What are the terms? Give me a term that you see. Negative x cubed is a term. What's another term? 15x. What's another term? 3. Okay, the pieces that make it up are the terms. So this is standard form. Yep. Now, looking at it, what is the constant? Why? It's a number without a variable. That's exactly right. What is the degree of this polynomial? The 3. Y'all said the degree was 3. That's correct. All right, this is a little tricky. What's the leading coefficient?
The negative.
No, the negative. Okay, so look. Good job, Franklin. When there's nothing there, there's a 1. So the leading coefficient is -1. Okay? All right. So I've got 2 terms to define for you. When a polynomial... Y'all got that? Ah! Sorry. All right. So a lot of times we define a polynomial by how many terms it has, okay? If a polynomial has 1 term, it's called a monomial, okay? Examples of a monomial are just the individual terms. Negative x cubed would be a monomial. 15x would be a monomial. Those are all monomials. Okay? 1 term. 1 term. 2 terms. No. Mono means 1. What means 2? Do you know? Binomial. Binomial means 2 terms. So maybe something like 5x squared plus 3. That's a binomial. It has 2 pieces. Then I have 3 terms, and we're only going to go up to 3. It's trinomial. So an example of a trinomial may be x squared minus 5x plus 2. That is a trinomial. They're all polynomials. Polynomial is the big umbrella that they're all under, and then there's different types of polynomials. Okay? X squared minus 5x plus 2. All right, so let me give you some examples, and you tell me whether or not, well, no, let's not do that.
That's what this was the lesson about. Just tell one.
No. All right, that's the background you need in order to do the lesson today. So, before we start, I need to define one more thing. Have you heard of something called like terms before? Tell me what, you know what terms are. We just talked about terms, okay? Number and variable with exponents, possibly, right? Doesn't have to have the variable. What does it mean to be like terms? Or give me an example of 2 like terms. Same base. Yes. Same base. Same exponent. All right, so over here, somebody's telling me an example of a like term. What did you say? 1x and what? Negative 1x. Or 1x and 1x, yes, that would work. Give me another example of like terms. 9x squared and let's make it a different coefficient so everybody sees. 7x squared. Those are like terms, right? The base is just the x. The number in front is the coefficient. But remember, the base is just the x. Okay, so that's what I'm looking. Give me another like term. Give me another set of like terms. Somebody, anybody. Anybody. Negative 1/2 squared and those are like terms. They're like terms because the variable is the same, the base, and the exponent. Okay? When those are the same, they are like terms. All right? So, with like terms, we can combine like terms, only like terms. When I say combine, I'm talking add or subtract. Y'all got this? All right, tell me quote again. All right, so we can combine like terms, meaning we can add them, okay? When we do, we only combine the coefficients. Yes, I did. The same base and same exponent means they're like terms. These two are like terms. These two are like terms. These two are like terms. Because the x and the exponent on them is the same.
The x is the base, the 9 is the
Okay, that's a whole fraction though.
It doesn't matter. It's the coefficient.
If you don't, the coefficient doesn't matter. You gotta worry about x and x on. Instead it could be fine, right?
Oh.
Remember the measure?
All right, we combine the coefficients only. We leave the base and the exponent. Okay? This will make more sense, I think, when we do it. We've done this a little bit before. We just haven't quite defined it before. Let's say I have 2x to the third that I want to add 5. Oh, no, let's don't do 5. Let's do 6x to the third. First of all, are those like terms and why?
Yeah.
Yes, why? The base, which is x, is the same, and the exponents are the same, right? They're both x to the third. So if I combine them, I only combine the numbers in front. I leave the base and the exponent alone. So it's going to be, that's right, we add the 2 and the 6, and the x to the third stays. That's how you combine like terms. Okay?
Yep.
That's what I said. Kind of, but not all the way. So what we're going to do is we're going to use this concept to add whole polynomials together.
I got a question about like terms though.
Yes, what's your question about like terms?
Okay, I still understand. Okay, so that's like that, right?
So, let's add polynomials. I think the easiest way is to show you through example. I think if you understand everything so far, you'll be A-okay. All right, let's say I have 2x to the third minus 5x squared plus x. Is that a polynomial? Yeah, it is, right? It's made up of one or more terms. Everything looks good. The exponents are positive whole numbers. Good to go. Let's say to that polynomial, I want to add another polynomial. Oh my goodness. Let me give you some tips as we go through here. Okay. Remember, we want everything in standard form, which means the biggest exponent down. That second polynomial is not in standard form. Not that we can't work with it, But in the end, we're going to have to put it in standard form. So as I add polynomials, I always start with the biggest exponent. Now, that's exactly what I was going to do. Whenever I first learned about like terms and adding polynomials, I did either different colors or different shapes so that I could keep in my mind which ones were like terms. All right? So let's start with the biggest exponent in the first polynomial, because all we're doing here is combining like terms. Okay? If I look at, and I'll just start with a circle, if I look at 2x to the third, anywhere in this problem, is there another x to the third? Yes, where?
On the right side.
Okay, I've got a positive x to the third. Do we agree? If you combine those, what is 2x to the third plus 1x to the third? 3x to the third. I am done with those, so I'm going to mark them out so that I don't confuse myself. Okay? I did. There's an imaginary 1. Nope, you leave it alone. Only the coefficients. Okay? Now, 3 is followed by, what comes next? 2, the power of 2, right? All right, so in this polynomial, and maybe now I'll do a square, I've got a power of 2. Is there a power of 2 in the second one? Yes. So what is, and be very careful, what is negative 5x to the second power plus 2x to the second power? Minus 3x to the second power. All right. What comes next? I've got 3, 2, 1. Do I have any ones? I've got one here, right? I'm gonna triangle this one. Here's a 1. Are there any others? No. You can, yeah, you can put it there and there. There's not another one to combine it with, so I just write it. And I'm done with that one.
What should do with the
Plus 1x over 1.
What?
What about the negative one?
I ain't got there yet.
You put
You just put minus 1.
plus 1x, and 1 of the x.
That's fine. The only thing I have left is this constant, so maybe I'll do a diamond. It's by itself, so it's minus 1. Okay? I am literally looking for the like terms and then combining them. Looking at my answer. Looking at my answer. Tell me this. What is the constant? Negative 1. What is the degree? What's the leading coefficient?
3.
See how we're doing this?
Yeah.
Let's do another.
Is anyone to label the parts on the test?
Yes.
Let's see what's speaking. Do we leave it
No.
like that?
Yeah, wants to get the negative.
We don't got a graph, do we?
Not yet. Now I haven't gotten to subtraction yet.
Wait a minute, so we go subtraction next one?
All right. Which one should I start with?
With the biggest degree.
The biggest degree, which is x squared. What's wrong, Shaija? Good? All right. With the squared, right? The x2. All right. So I've got a 3x squared in the first one. Do you see any more x squareds? What is 3x squared plus x squared?
4x.
I'm done with that one. Now, on to the next one. X. Do you see another x?
Yes.
What do you get when you combine those terms?
Plus.
Una más, una más.
Then plus 4 is 2 constants.
Then plus 4. That's right, 2 constants. What's the constant of that polynomial?
4.
Degree?
2.
Leading coefficient?
4.
What classification would this polynomial have? Trinomial, because there are
3 terms.
3 terms. Good job, y'all.
That's it. That's
Let's
the
subtract.
Oh.
You thought? Oh. Subtract polynomials. Subtracting, really, if you think about when you learn to subtract numbers, subtracting is just adding negatives, right? It's the same thing. So, let's say I have 4x squared plus 5, and I want to subtract negative 2x squared plus 2x minus 4. I'm subtracting everything in parentheses. So what you need to do, what did you do when you subtract two numbers before? Like if I said, what is 3x minus 5x? Okay, yeah, you can. When you subtract, what is it y'all do? I'm looking for a little thing y'all say all the time. When you subtract. Come on, guys. Same, change, change. Why do y'all act like you've never heard that before and y'all say that all the time? Same, change, change. What you're going to do is the first polynomial, it's going to stay the same. Okay?
What?
The whole polynomial stays the same.
Why?
So the first polynomial, keep the same.
I don't see the same kind.
Then you change the sign in the middle. So this one becomes a plus.
My handwriting is so cute.
But then we have to change everything in the parentheses that follows it.
Oh, girl, look at them C's in there. I don't use C's. I use K's. But, you know,
So change, change, change.
Okay, further, my C's and my A's look so good on this paper. Oh.
All right, shh, shh, shh. Does everybody see what we've done?
No, ma'am.
I was subtracting two polynomials. When you're subtracting two polynomials, change it to addition. So do same. This whole first one is same. Change the sign in the middle and then change everything that follows it. Everything in parentheses that follows it, change sign.
Let me see that.
Okay? So what I have now is an addition problem. And we've already... The same, change everything.
Oh my God! Wait a minute! Please start over. I'll write it down. Can you do it again, please?
All right. When I same, change everything. Okay? I kept this one the same. I changed the sign in the middle. And then I change all the signs inside the parentheses.
And you have the every minus sign and this error subtract part?
I left what?
You have the error subtract part?
Yep. So now it's an addition problem, which means I need to gather up my like terms.
4L.
All right, that's right, Zaya, go ahead. 4x squared terms up with what? And it's positive now, right? Because I changed it. What is 4x squared and 2x squared?
Okay, do we still need to look at the function number?
Yes. All right, so now I've got a power of 2. What's the next power I need? 1. Do I have any powers of 1?
No.
Look at this one. I do.
Oh, yeah.
Okay, nothing goes with it. It's on its own. It's a loner. But it's still a negative 2x, right? And I'm done.
The constant.
And then the constants. Yes, you're right, Kennedy. It's plus 9. So really, subtracting is just adding. You just have to rearrange it or change it a little bit before you add it. Okay, let's do one more.
You do the homework.
Let's do one more together first.
Is it one in the homework with fractions?
Can you do what we did last time?
What we did last time?
Or we do the homework and the people who don't get it have to do another one.
No, because I'm doing one more. Everybody all together.
Yeah, what we did that?
How do people come up with this stuff? Like,
Yeah.
how do they?
Did what again? What we did?
What off of Einstein's fault? What idiot came up with that?
Oh, I'm slow. I thought y'all was saying that.
Guys, boxing back to this. All right, 3x squared minus x minus 8. Y'all are just getting started in your math careers. You're whining now. Goodness. All right, so this is subtraction. Yes.
When this is subtraction, you change the.
That's subtraction?
So you same,
The whole
you
thing?
change, and you change. I sound like Dr. Seuss. You same, you change, change.
Anyway.
What a blue fish. All right, let's get our like terms together. What? Well, but you got to change that first. Yeah, you got to change that first sign. So what is 4x squared and negative 3x squared?
So you had to put that there right now?
Yep, because everything in the parentheses changes. What's 4 minus 3? X squared. 1x squared. And I'm done with that one. What is negative 3x and x? Negative 2x. Good job. And then finally, my constants, 13.